Hello and welcome to today's lesson. Before we start, for this lesson you will need a pen, a ruler, a calculator, some paper or an exercise book, and no mobile phone unless you're using this to view the video on. Best off, remove any distractions. If you need to pause the video to go get the equipment, then please do so now. Today's lesson is the first of two lessons where we will be looking at investigating electromagnets. In today's lesson we are going to focus on writing a method. So we're still continuing with our topic, how do magnetic fields produce electricity? But in today's lesson we're going to specifically look at what we must do to make sure our methods are reproducible. First of all, a starter then, true or false? Three statements, are they true or false? And as a start task, can you name me 4 magnetic materials? Okay, so magnetic fields go from south to north. That is false, they go from north to south. The magnetic field is stronger at the poles of the magnet. That is true. An electromagnet is a magnet that produces electricity. It isn't. It's a magnet that uses electricity to produce magnetism. And the 4 magnetic materials are iron, cobalt, nickel and steel. So in today's lesson we're going to focus on writing a method for an investigation. And here I have a method for making the perfect cup of tea. But the person here has been a little bit brief. Can you look at the method and using the success criteria, can you suggest ways in which to improve the method? So we need to have it written in a clear and logical way. We need to state all the equipment that is needed, and we need to give specific measurements for amounts. I'm going to give you 3 minutes to see if you can improve that method. Okay, so let's have a look at an improved version and see which points you got. So it was step by step, but it wasn't very detailed, was it? So first of all, we need to put amounts in. So I would heat 300 centimetres cubed of water using a kettle until it boils. And I know the boiling point of water is 100 degrees centigrade. I would then place a tea bag, and my favourite tea bag is a Yorkshire tea, so I would place a Yorkshire tea bag in a 350 centimetre cubed mug. So again, I'm saying the size and the equipment. I would then pour the boiling water over the tea bag. I would stir it for 5 seconds and then I would leave it for a further 120 seconds. I would then remove the tea bag and I would add 10 centimetres cubed of semi-skimmed milk and stir for 5 seconds before I drank it. So why is a method important and why do we need them? Well, a method is a systematic way of doing things. It gives people clear instructions. So if you're following a recipe at home on how to bake a cake, you want very, very clear instructions on how to do it. But if a method is well written, then it will give reproducible results. And reproducible results mean that 2 different people could follow the method and not get exactly the same results, but get results that are very similar. Just like baking a cake, 2 people could follow the method and their cakes might be slightly different, but they were basically very, very similar. So thinking about practical skills then, the point of a scientific investigation is for us to test something called a hypothesis. And a hypothesis is a statement that says what you think will happen. And then your investigation is to work out if you think that is true or false. So we've been looking at electromagnets, and last lesson we looked at if we wrap a wire in a coil, create a solenoid and put that around an iron core, then it would create something called an electromagnet when we turn the current on. So what I'd like us to investigate today is, does increasing the number of wires wrapped around the iron core increase the strength of the electromagnet? You can see here I've got 2 electromagnets, and the one on the left has 3 paper clips and the one on the right has, looks about 11 paper clips. So which one of those images do you think shows the strongest electromagnet? That's right, the one on the right, because it's managed to pick up the most paper clips. So thinking about our hypothesis, increasing the number of coils wrapped around an iron core increases the strength of an electromagnet. And the things that I'm going to use, the equipment I'm going to use to test this, is some insulated copper wire, insulated so that we don't electrocute ourselves, an iron nail because that's my iron core, a battery, or we could use a power pack, and some steel paper clips. So here's an example of a method to test this hypothesis. Make a circuit, wrap the wires around an iron nail, hold the nail over some paper clips, count how many are attracted to the nail, add more coils, repeat the experiment, record your results in a table. But would this be reproducible? Would 2 different people be able to follow this method and get similar results? Think about the task we did earlier when we made the cup of tea. What did we change? How did we improve that method? That's right, we're going to need to be a bit more specific then. So we're going to have to talk about the number of coils round the wire. We might want to talk about the things that we are going to change, the things that we are going to keep the same. So thinking about that method, what will you change each time you do the experiment? That's the independent variable, what I change. What are you going to measure That's the dependent variable. So what's going to change each time that's going to show you a difference? And really importantly, what are you going to make sure that you keep the same each time so that your results are reliable? These are known as the control variables. So I'm going to give you 2 minutes to have a think about those 3 questions. Okay, so in this experiment, we are increasing the number of coils of wire. So our independent variable will be the number of coils of wire. What we're measuring is how many paper clips that it can pick up. So the stronger the electromagnet, the more paper clips it will pick up. So it's the number of paper clips. And then things that we're going to have to keep the same. We're going to have to make sure that the core stays the same, the wire stays the same, the length of wire stays the same, the potential difference of the power supply stays the same, and we need to use the same type of paper clip. So all those things are important to keep them the same. So here we have 3 different diagrams of somebody's experiment. Would they be able to compare the results from each of these experiments? And if not, why not? 1 minute to have a think about that. Okay then, so having a look at these then, these are not comparable. So they have different numbers of coils of wire. So that's okay because that's our independent variable. We can change that. However, they've also got different voltages on the battery. Well, that's not comparable, is it? Because if we change the voltage, then we're going to change the strength of the electromagnet. They've also got different length nails. So that means they're also going to be changing the core, and we need to keep that the same. They've got different nails as well. So we've got 2 of them are iron nails, but 1 of them is a steel nail. The length of the wire changes from each one. So again, that's not comparable, because when we were looking at current recently, we saw that that varies with the length of the wire. And they've also got different materials for their wire. And in our previous lesson, we looked how resistance changed with different materials. So apart from the number of coils, we need to keep everything else the same. Okay, so what I'd like you to do for the remainder of this lesson is to write a step-by-step method to describe to another student how to test the hypothesis that increasing the number of coils of wire wrapped around an iron core increases the strength of the electromagnet. And remember our success criteria. Our method must be written in a clear and logical way. Step by step, bullet pointed is the best way to do that. You need to state all the equipment that you are going to use. And you can see the diagram I've got on the right hand side here shows you all the equipment that you need. You need to describe how you are going to change the independent variable, so the number of coils of wire, and I would give specific numbers, maybe changing them by about 5 each time. That's a nice number to go up in. And then finally describe how you're going to measure the strength of the electromagnet. So that will be about counting the number of paper clips that the magnet attracts. Okay, so you can go away and do that now, and we'll see you next lesson for the practical.